Hello, everyone. My name is Adrian Herrera, and I am the VP of Marketing for Caringo. We are very excited to take part in ISE 2020. Our presentation today is going to be about how object storage enables data visibility, multi-tenant access, and protection. For those of you that don't know us, we are object storage pioneers. We were founded in 2005, and one of our primary verticals is high-performance computing. We work with a number of different research facilities around the world, and we will walk you through some of the benefits they get from using object storage. We'll then go into why Swarm Object Storage is a little different than other object storage solutions out there in the market, and we'll wrap up with 2 real-world use cases. From a very high level, just to set the stage here, I wanted to define object storage. I don't want to spend too much time here. If you're interested in the subject, go ahead and type in back to basics object storage in Google, and a great asset, a great webinar, and a great blog that we have worked on that's very popular will pop up. You'll see this graphic. We go into it in detail. The way object storage really differs from file and block is object is a flat namespace. If you store an object on Swarm or on any object storage solution, you will get an ID. You can then use that ID to find that piece of data anywhere within the solution. A lot of the times, or most of the times, you can access that directly over the web. So it makes it very, very easy to find a single piece of content in billions and billions of files, where that would be pretty difficult to do on file and block-based storage. From an issue perspective, here are the issues we hear most often from our HPC customers. They struggle with scale. They struggle not only with capacity, but also being able to store billions and billions of files and being able to deliver and find those files whenever they need to. They struggle with providing access to data sets, not just to specific applications and specific users, but providing metered access that could be measured, because a lot of the times HPC organizations are service providers. They provide services to the underlying infrastructure that they have, compute services, storage resources, or networking resources, storage capacity, that kind of thing. They struggle with being able to find and share data. You know, that is part of the exabyte scale and tenant management also. And underlying all of this is manual administration. A lot of the times, everyone is dealing with constrained resources. So when you ever have to do anything manually at scale, it's very difficult to do. And of course, if you're growing, if you're experiencing hyper-growth or hyperscale, it's extremely difficult to maintain manual processes, manual administration. I'm going to go over 2 workflows that we typically see in the HPC world. The first is multi-tenant access. So again, organizations that need to provide access to different users, different devices. And this is where Caringo differs from a lot of organizations. We not only enable you to provide secure access to shared resources, we allow you to measure that access, whether it's based upon how many times they're accessing that specific data or how much capacity you want to give a particular user, a particular device. We also provide a web-based UI to search for content. And once you find the content you need, you can customize the metadata. You can also share that directly via the UI, and we have examples of that. A lot of the times, organizations are trying to facilitate collaboration, but they're also trying to optimize primary storage resources. So if you have a particular device that's using primary storage, SSD, something very expensive, and you need to offload or move data off for the next project, we're a great way to do that. You go ahead and you optimize your primary storage, and then you make that data accessible. It's still archived data, but it's searchable, it's instantly accessible, and you can share it. You go ahead and you offload your primary storage. So you save your investment there. You make that primary storage faster because it has less data on it. You put it on a highly scalable pool of storage like Caringo Swarm Object Storage, and then you can continue to provide access to that to researchers around the world. Workflow 2 is similar. In this case, we are back-ending a parallel file system. You can use a number of different protocols just like you could in the initial workflow. You can use S3, NFS, or some sort of hierarchical storage management application. Most organizations have, their favorites out there. You would send that data to a tier 2 active archive, in this case, object storage, Swarm Object Storage. And then you can provide access over the public cloud. You can send that data to maybe a more long-term colder archive solution like tape, like LTO, or you can send it to different remote sites. We have integrated distribution functionality built into our solution, so it's very easy to do. We provide that via a web-based UI. Again, we won't go into too much detail on the functionality and how you set up Swarm, but we have a lot of great videos on Caringo.com if you want to dive into any one of those discussions or topics. We went over the workflows. Now I'm going to spend a few minutes just going over from a high level the functionality that is helping our HPC and our research customers around the world. We really focus on eliminating complexity and streamlining deployment. At our core, we're software. We run from RAM. That means that we leave 95% of the actual hard drive capacity for data. You don't have to install an operating system. You don't have to install a metadata database. We take care of that, all of that for you. So it's very easy to maintain and administer our solution. We have single administrators managing 10 to 20 petabytes on their own, and they're just part-time resources from a management perspective for the object store. So it's very, very easy to manage. And we focus on really being able to scale quickly and efficiently. So once your cluster is deployed, it really only takes a few seconds to plug additional storage resources, whether that's for performance or capacity purposes, into the cluster, and everything just automatically joins a cluster, and those resources are available. This is really important. Mixing and matching hardware is also very important from an HPC perspective. Because a lot of the times when you're dealing with grants and we're dealing with projects, you don't get the funding all at once. You get the funding for a certain amount or certain portion of hardware. A lot of times it doesn't cover an entire server. So the ability to mix and match hardware, you don't have to worry about growing pains in the future. If one of your clients or one of your projects gets approved, you can go ahead and scale by the drive if you'd like. It's very easy to do that with us. We facilitate collaboration and measure utilization. Again, we're finding this is very, very important in the HPC space, the ability to measure utilization and be able to tell who accessed what, who's using what kind of, or how much capacity they're using. In the HPC world, that's important for a few different reasons. A lot of the times you want to assign resource utilization and ultimate cost to a particular project, to a particular grant. It's very easy to do that with us. And a lot of times you just want visibility to make sure, to ensure that everything is happening correctly on your solution or on the services you're providing via Swarm. And again, all of this is managed on the server. You can revoke access at any time. You don't need to manage access and authorization via spreadsheet anymore, by passwords and usernames. You can go ahead and give passwords and usernames, and if at any time you want to go ahead and revoke access, you can go ahead and do that, and it's all done via the server. We provide a web-based UI to do it. You can also do it via an API, so it's very easy to integrate into third-party tools, management tools, if that's what you'd like to do. Again, we focus on protection. Object storage is all about providing scalable storage that heals itself. It's really all about ensuring data availability, making sure that your data is protected at all times. That protection is customizable. We have some great resources that walk you through replication and erasure coding on our website. What I want to share with you here is you can mix and match erasure coding and replication protection schemes based upon your business requirements, based upon your performance requirements. So if you do want to make data more accessible, you would use replication, you would create copies. If your goal is to optimize your data center footprint, then you would use erasure coding. where you can get RAID 5, RAID 6 like durability with only 40 to 50% hard drive overhead. And of course, we're very secure. We provide worm, 256-bit encryption, versioning, and integrity seals. So the ability to provide a hash of a particular piece of content in a way where that hash is upgradable. So if for some reason some hashing algorithm gets compromised, you can go ahead and upgrade that. This is where we differ than most object storage solutions on the market. We also provide a content UI. So your users can not only self-service from a utilization perspective, seeing what they're using, what their access is, what their capacity is, they're also able to look at the content that they have stored in their shared portion. They only have access to their shared, their account. I don't want to say account, but the portion of the infrastructure that you give them access to. There's a web-based UI. They can go ahead and search based upon the metadata that's stored with the object. They can customize that metadata. So it's very versatile. It's simple yet very versatile. And we also include some unique functionality like partial file restore, which enables you to take a clip of a larger video file. For HPC workflows, if you have satellite imagery or some other large video and you only want to share a portion of it, this makes it really easy to do that. You can just clip that particular portion and share that link with researchers with different organizations. It's very easy to do. We enable distributed workflows. You can set data sets or subsets to different swarm clusters, regardless of their location. You can also back up to any S3 compliant service. So you're doing two things. You can easily and efficiently automate the sending of data sets to different locations, and you're also adding a second layer of protection above and beyond the enterprise protection that's already built into Swarm. Object storage by its very nature is highly durable. Most solutions are able to heal issues and recover quickly. Where we differ is we really focus on proactive recovery. We'll go into that in a bit, but because of our parallel architecture, because all nodes do all things, it gets very, very fast as a cluster grows. From an administration perspective, we really focus on automation. And again, I mentioned one of the issues that the HPC space in general struggles with is manual administration. From a system status perspective, you can view system status at any time. You can drive down on information on chassis or particular drive, see what the status of that particular drive is. We have a UI that does that for you. We plug into SNMP. You're also able to export that data via Elasticsearch to Grafana. So we not only use Elasticsearch to customize metadata and to search for content, we also use it for the status information that we store about a Swarm cluster. So you can export that data and view it in Grafana. So if you're users of Grafana, you can visualize that information. We have a dashboard, a Grafana dashboard that's very easy to integrate to. We also provide proactive monitoring, real-time alerting, and detailed reporting. So all of this is to ensure that you have visibility into the solution. A lot of the times, Swarm will go ahead and heal itself. You don't have to take care of the issue right away, but at least you know of the issue. There's a lot of different ways for you to get notified about that particular issue. Now I'm going to walk you through two use cases, very high level. The first is Science and Technology Facilities Council, STFC, at Rutherford Appleton Laboratory. They're using our solution as the object store behind the Jasmine project. So Jasmine essentially is compute and storage resources, supercomputing compute and storage resources that are used for a lot of different climate and environmental projects around the world by different research facilities. They had some pretty unique requirements. They needed to store and access petabytes of information, scaling to the triple digit petabytes. So they needed to be very, very scalable. They needed it to support very large and very small files. And most importantly, for supercomputing resources, it needed to be low latency and really leverage the 100 gigabit network that they have. The results that they achieved, we enabled scalable storage services. So we enabled them to provide the type of underlying services they needed for their archival storage. We provided them with S3 access, which they're then able to share with their users. They have NFS access to that same object, so there is a single namespace for both NFS, which is a file system protocol, and S3, which is a new RESTful interface. And we enabled them to be able to manage all of this via the server, so that they're no longer doing manual management for access to this information. They can now manage it directly on our UI via the API. They have a few different ways to do that. And most importantly, we met their aggregate throughput goals for S3. So they wanted it to be similar to parallel file systems from a read perspective, and we achieved that. In fact, we were quite a bit above the minimum requirements. And if you're interested, you can go ahead and go to caringo.com, resources, object storage, performance benchmarking, to get very detailed information about this particular use case. The second use case is Argonne National Laboratories. Similarly, they're providing services, cloud services to researchers. And again, they're using us as the underlying object infrastructure. They had similar requirements. They wanted to consolidate information, provide access to that data. They're able to do that all and provide web-based storage provisioning, metering, quotas. They also plugged into an existing solution they had with Globus, which is an authorization, nonprofit authorization platform. It's a great service that hundreds of researchers are using around the world. So they're able to plug our object storage solution right into what they're already doing with Globus. And from a high level, here are the benefits that we bring to the HPC space or HPC workflows. You can consolidate data and eliminate storage silos. You optimize acquisition and compute storage capacity. And you're able to provide a secure metered storage service. So really providing private cloud storage, private S3-like cloud storage from your data centers to your researchers, to your students, to the different applications and devices that need shared storage. And with that, I'd like to thank you for your time. My name is Adrian Herrera. I'm the VP of Marketing for Caringo. If you'd like to send me an email, you can just send it to info@caringo.com and it'll get to me. Your regional representation or representative will be Paul Phillips. He is our Sales and Operations Director for the EMEA region. Again, we have a number of great resources, HPC resources on caringo.com. I encourage you to visit our webinar section, our blog section. And if you have any questions at all, just reach out to Paul or send an email to info@, and we will get back to you. Thank you so much for your time.